Cleaning of dishes in a commercial dishwasher centers around the circulation of water. The water carries detergent, heat, and pressure used to remove food soil from the surface of the ware. The heart of this circulatory system is an electric motor connected to a pump. Although models and configurations vary, this tutorial will provide an overview of key components of the pump and motor, basic pump operation, interpreting the motor's data plate, and proper motor wiring. The assembly is divided into two parts, the pump and the motor. The pump consists of a housing made of two halves. These two halves are bolted together with a gasket or O-ring to create a watertight seal. The front half is called the volute and directs water in and out of the pump, while the back half, called the base, offers stability to the pump's moving parts. Inside the pump is the impeller, which is attached to a metal rod called a short shaft. The short shaft passes through a pump seal and connects to the motor shaft. Also on the motor shaft is a rubber washer called a slinger. This washer prevents water from traveling into the motor in case the seal should ever leak. The motor connects to the pump with 4 bolts from the base, allowing room for the motor's shaft. This shaft protrudes from the body and spins at 3,450 revolutions per minute. In order for the shaft to spin evenly at such a high speed, the motor has 2 or more bearings inside the body which hold the shaft in alignment with the pump. Also spinning with this shaft is an internal fan and a large piece of metal called a rotor. The rotor spins inside an assembly called a stator. Together, these two items convert electricity into movement which spins the shaft. The stator is comprised of a series of copper coils which can often be configured for 2 different voltage inputs, 120, 230 being the most common. On the motor's exterior, you will find a capacitor, an electrical access cover, and the data plate. The capacitor is a device used for storing an electrical charge and will be explained in future tutorials. Until such training is received, it's better to leave the cover for the capacitor in place. Failing to do so may lead to injury. The electrical access cover protects the motor's wiring connections and is removed only during troubleshooting or motor replacement. Should you remove this cover, ensure power to the machine has been isolated and proper lockout-tagout procedures are followed. Once the cover is removed, several electrical terminals are revealed. Look closely and you will see the terminals are numbered 1 through 6. These numbers are landmarks for ensuring wires are connected to the correct terminals, but more about this shortly. The last item to examine is the motor's data plate, which is a sticker that provides key information about proper installation and operation. Sometimes the motor will appear to be missing its data plate. In these instances, it's often covered by a protective film the same color as the motor's body and needs to be removed. Although there are many pieces of valuable information contained here, there are about 6 which are vital to know. Horsepower. The horsepower is an indication of the motor's strength and is related to its power consumption. Always replace motors with the same horsepower value. The voltage of the motor is listed as either a single or double value. In this case, the 120-230 indicates the motor is capable of operating with either 120 or 230 volts, depending on how it's configured internally. The first number listed is referred to as the low voltage, while the second number is the high voltage. The terms low and high only refer to the order the numbers appear and are not related to the amount of power involved. The amp draw indicates the amperage flow at the motor's low and high voltages. In this example, the motor will draw 13.2 amps at 120 volts and 6.6 amps at 230 volts. Thermal protection. This indicates the motor has an internal device which monitors the buildup of heat and shuts the motor off if it gets too hot. A motor not having thermal protection means it needs some type of external circuit protection like a fuse. Motors without thermal protection should never replace motors with thermal protection. CW indicates the motor spins in a clockwise direction, while CCW is counterclockwise. Although it is possible to change the rotation on some motors, this only applies to larger 3-phase motors and 1-phase motors where directions are listed. This motor only spins clockwise. For a multi-voltage motor, the wiring diagram is split into 2 sections. The left section, labeled as low, indicates wire placement on the terminals when the lower voltage is applied, in this case 120 volts. The right section, labeled as high, is for 230 volt applications. The circles indicate terminal numbers found under the electrical access cover. The information found to the left of these circles indicates wires within the motor, while the information to the right indicates wires from the machine. The wires from the machine are labeled as line 1 and line 2 because they could be different colors depending on application. A ground wire is not typically called out in these diagrams because it is assumed technicians know this is a legal requirement. Wiring of the motor is completed by following the diagram. To do this safely, follow these steps. Number 1. Disconnect power from the machine and use proper lockout-tagout procedures. Number 2. Identify the 3 wires coming from the machine. These wires are coming out of the conduit that's attached to the motor and are typically black, white, and green. Move these wires aside in order to have a clear view of the terminals within the motor. Number 3. Look at the wiring diagram and notice that the brown wire and red wire within the motor must be attached to terminal 2. Confirm this on the terminals. Number 4. Refer back to the wiring diagram and see the motor's blue wire is to be connected to terminal 4. Confirm this on the terminals. Number 5. Return to the 3 wires coming from the machine. Locate the green wire and connect it to the ground symbol. The ground symbol is an isolated terminal connected directly to the motor's chassis. Of the 3 machine wires, always connect this wire first. If it is not present, then a new wire must be installed. Number 6. Locate the white or neutral wire coming from the conduit. This wire is referred to as line 2 on the diagram and is attached to terminal 1. Number 7. Locate the black or hot wire coming from the conduit. This wire is referred to as line 1 in the wiring diagram and is attached to terminal 4. For attaching this motor to 230 volts, follow the same process completed here, but be sure to follow the high voltage diagram. Once wiring is completed, reattach the access cover and reapply power to the machine. After the wires are connected, the motor can receive power and turn its shaft. Turning the short shaft of the pump spins the pump's impeller. This starts water moving into the pump through the center hole of the volute. Because the impeller is spinning in a clockwise direction, the water is scooped by the impeller and flung outward. This builds up water pressure and forces water to leave through the upper hole and onto the wash arms. The angle of the wash arm jets combined with the pressure of the pump forces the wash arms to spin and spray water throughout the wash chamber. This water then collects at the bottom of the tank where the pump is able to draw it into use again. In this video, we've identified the key components of a motor and pump, explained how each functions, and showed proper wiring. Although this video should cover most instances related to this assembly, viewers are reminded that there is no substitute for attention to detail and proper safety precautions. Should your circumstances not be covered by this tutorial, it's recommended that you seek additional assistance before attempting any action.